only 8% of our fate is genetically determined, and 92% of our fate is determined by both the fate of our microbiome, the bugs that live in our gut, and these environmental factors like epigenomics.
I am really pleased to be joined on the Freedom Pack podcast today by multiple time New York Times best-selling author Dr. Gundry. His new book, Unlocking the Keto Code, we'll be talking about today. Dr. Gundry, thank you for joining me on the Freedom Pack podcast.
Pleasure to be here. Thanks for having me.
So, the subtitle of the book reads, The Revolutionary New Science of Keto that Offers More Benefits Without Deprivation. Now, that bit caught my eye because I think a lot of people may have heard of the keto diet and they may have this thought that it's a boring, unexciting diet. They're going to have to sacrifice so much out of the enjoyment of food. What would you say to those people that think like that?
Well, they're right that a traditional keto diet is exactly that. It is a boring sacrifice, lots of foods that you love. And in fact, 60% of people who go on a ketogenic diet quit within a month because either they just can't stand the boredom, or there's really an innate craving for carbohydrates that I talk about in the book. We're actually hardwired to seek out carbohydrates. This has been shown by researchers from the University of Sydney in Australia. So it's no wonder that it's so hard to do a traditional keto diet.
I first came across a traditional keto diet. I've worked in the fitness industry for a couple of years now, and there's so many bodybuilders that you see coming to the gym who are getting ready to jump on stage. And when it comes to that sort of bottom end of fat loss, they all seem to finish off with a strong keto diet to finish. But for everyone listening right now who may be brand new to this subject, they don't have a clue what we're talking about, could you just define what a keto diet is?
Sure. Believe it or not, the term ketogenic diet was coined in 1930 by doctors at the Mayo Clinic in the United States who found that children with seizures, and there were no anti-seizure drugs back in those days, could have their seizures controlled by following a diet that was 80% fat, 10% carbohydrates, and 10% protein. And they knew, actually, from experiments in starving kids, that that sort of diet would produce ketones. Ketone bodies are water-soluble fat molecules that can actually get into the brain when other fat molecules can't. And they can actually keep the brain alive, but they also found that ketone bodies seem to prevent seizures. And that was was actually quite miraculous. Over 50% of kids had control of their seizures before these drugs came along. The ketogenic diet fell out of favor for seizure treatment when drugs came along, but it actually had a resurgence in the 1990s because even though these drugs were great at controlling seizures, a lot of these kids and adults had, lack of a word, their brains didn't work very well. They were slow, they were brain fog. And so there was a resurgence of a ketogenic diet based on MCT oil, medium chain triglycerides. And I think that's really important for readers to understand, is that what they found was that MCT oil, and we'll talk about that as we go along, is unique in that it's absorbed directly from our intestines, unlike any other fat. And it goes directly to the liver, where no matter what you eat, your liver generates ketones. And so what they found with kids is that they could put them on an MCT oil-based diet with much lower amounts of fat and give them a lot more carbohydrates and a lot more proteins. And those of us who have children or now grandchildren know that it's pretty hard to deprive a kid of carbohydrates. And of course, most of us adults know it's pretty hard to deprive yourself for long of carbohydrates. We just seek them out. So it turns out that this MCT oil-based ketogenic diet worked just as well as this draconian 80% fat diet. And that's how I got interested in it about 20 years ago.
So for everyone listening who may now have a little understanding of what we're talking about, but they're thinking, is this a diet for me? Who is this diet for? What would you say in terms of who is this diet targeted at? Who does it alienate, if anyone?
Yeah, so originally the ketogenic diet was really targeted at not only athletes, but also people with metabolic syndrome, metabolic inflexibility, pre-diabetes, high insulin levels. And it was found, and still is found, that these sorts of diets, high fat, low carbohydrate diet, really did improve or cure type 2 diabetes or insulin resistance. And there's a lot of good things about that. There were two researchers in primarily the 90s and the 2000s who praised the ketogenic diet for athletes, but in fact, their data was very suspect in a lot of ways. Let me give you an example. There are two very famous researchers in ketones. One, George Cahill at Harvard, and also Richard Veach at the National Institutes of Health. And what they found in human subjects is that even though you go into ketosis after about 12 hours of not eating, it can take several weeks to get keto adapted in athletic performance. But here's the shocker. At full ketosis, when your liver is pumping out ketones, which are supposed to be this magnificent fuel, only 30% of our energy needs can be met by using ketones at full ketosis. Now, that doesn't sound like a super fuel. And if it's a super fuel for the brain, even at full ketosis, the brain can only get 60 to 70% of its energy needs met by ketones, and the rest has to come from glucose, from sugar. So that whole concept that ketones and ketosis is how we ought to be 24 hours a day, 7 days a week, just doesn't bear up to, human research. And yet that's what you hear over and over again, that we should always be in ketosis, that it's a super fuel, it makes us efficient fat burners, and that's why we lose weight. And in fact, as the book points out, it's actually 180 degrees wrong on how ketones are beneficial.
So what is your approach to the keto diet? What message are you trying to get across?
Well, so I've had a ketogenic version of my diet, the Plant Paradox, which many people know. It's a very popular book in the UK. Thank you very much. So my version of a ketogenic diet was, let's have a lot more carbohydrates, but let's use MCT oil and get the benefit of ketones without just, ladling on buckets and buckets of cream cheese and sour cream and butter and bacon. And, let's pour bacon grease on our hamburger. And, that's fun for a couple days, but after a while, it just doesn't taste very good. So, and I found that even though I was giving people a lot more carbohydrates, we still had people lose weight, their diabetes went away. And I used to write that, well, that's because ketones turn you into an efficient fat burner, and it turbocharges your mitochondria, those little energy or producing organelles in all our cells. And if you think about it, particularly now that we have our latest gas crisis, if we're trying to save gasoline, if we're trying to maximize our use of gasoline, then we would want a very efficient car. And so, for instance, a Toyota Prius is a very efficient car. On the other hand, if we wanted to waste gasoline, then I'd buy an Aston Martin. Aston Martins are really good at wasting gasoline. Now, there might be other reasons I'd want an Aston Martin, and I'm sure you would too, but it's not a good way to save on gas. So if you think about it, this concept that ketones make you an efficient fat burner, and that's why you lose weight, doesn't pass the sniff test. So what ketones do, and what I discovered, was that ketones are not some great fuel. They don't make your mitochondria more efficient. But in fact, instead, ketones are actually signaling molecules that tell your mitochondria, as strange as it may seem, to literally waste fuel, to stop being a Toyota Prius and become an Aston Martin. And it's because these mitochondria literally waste calories in the production of ATP. You literally do a caloric bypass when stimulated by ketones, you lose weight. And it turns out that not only do mitochondria waste energy to protect themselves from damage, which hopefully we'll get into is a rather important concept, but under the presence of ketones and other substances that we'll talk about, your mitochondria are told to make more of themselves. Now, mitochondria are really unique. Mitochondria have their own DNA. Most of us think the DNA is in the nucleus, but mitochondria have their own DNA, which means the mitochondria can divide and grow and make more mitochondria without the cell they're living in having to divide at the same time. So what that means is, under the right stimuli, and ketones are one of those, ketones can tell one mitochondria to make 6 mitochondria. Now, let me use an example. In North America, we have dog sled races. And if I had one dog pulling my sled, the dog could pull the sled, but we wouldn't go very fast, and the dog would get tired, and we wouldn't go very far. But the dog wouldn't eat much because he's one dog. Now, imagine if I hooked up 6 dogs to the dog sled. We'd go a lot faster. We'd go a lot farther because each dog only had to do a 1/6 of the work that the one dog would. The only downside is we now have to feed 6 dogs instead of one dog. So this is actually a really good example of how ketones work. It tells mitochondria to do less work individually, which is really good for the mitochondria. They don't get tired out and damaged, but they tell mitochondria to, hey, make a lot more of your cells so that each mitochondria does less work, but the full effect is it looks like you get more power, but you lose weight at the same time. So for most of us living in the West, losing weight is a pretty good idea. And unfortunately, for most people, it's very hard to do. So this is an easier way to get the things we want and still enjoy ourselves while eating food we like.
I want to make sure we define everything for everyone who's listening. And we talked a lot today about the mitochondria. When I was studying for my personal training qualification, they always described mitochondria as the powerhouse of the cell. Could you just explain the role of the mitochondria before we move on any further?
Yeah, absolutely. So Mitochondria are indeed the powerhouses of the cell, and they have a very fascinating history. We're pretty convinced that 2 billion years ago, ancient cells ate a bacteria, and instead of digesting the bacteria said, hey, I'll make a deal with you. I'll create energy. I'll make ATP, adenosine triphosphate, in exchange for you giving me something to eat and a nice home to live in. And apparently it was a really good deal because all advanced life forms on Earth, plants, animals, are what are called eukaryotic cells, where we use mitochondria, which are literally ancient bacteria, to produce ATP. And obviously that was a good deal. Let me just give you an example how good a deal it is for a cell. So a cell without mitochondria can produce ATP by what's called glycolysis. We know it as fermentation. For every molecule of glucose, every sugar molecule, you get 2 molecules of ATP by glycolysis. Imagine this, a mitochondria for every molecule of glucose gives you 32 molecules of ATP. Talk about a great trade. And in fact, why should we need that much? Well, as I talk about in the book, the average human being generates 140 pounds of ATP every day. And you go, wait a minute, 140 pounds, I don't weigh 140 pounds. I don't eat 140 pounds of food every day. That's impossible. Well, we spend 140 pounds of ATP as our energy currency. So when we think about powerhouses of the cell, these guys, I mean, talk about work. It's prodigious work. And the bad thing about producing energy in mitochondria is that, as strange as it seems, producing energy is very damaging to the mitochondria. People hear about free radicals or ROSs, reactive oxygen species. And this is part and parcel of the damage that happens to mitochondria as they're trying to produce energy. And that gets into why it turns out mitochondria have a protection system to avoid this damage. And they've got a crazy name called mitochondrial uncoupling. And I didn't make up the name. It was actually discovered back in the 1970s. And quite frankly, as I was writing the book, I spent maybe 6 months trying to figure out a better name for mitochondrial uncoupling. But sadly, it's in the literature. And so people have to get used to the concept of mitochondrial uncoupling. You want to talk about that?
Yeah, so in the book, am I right in thinking that you say a normal functioning body, mitochondria waste about 30% of all incoming fuel?
Yeah, which is shocking. You'd think, since for most of, animals' existence, human existence, getting enough food to eat was, the big deal. Now, of course, we have no concept of getting enough food to eat. We always have food to eat. But so it turns out that mitochondria, you'd think, would be very efficient at producing ATP from the calories we eat. But at rest, 30% of all the calories that go into the mitochondria to be turned into energy are literally thrown out side doors in what's called the electron transport chain and not used as fuel. And instead, these side doors are controlled by uncoupling proteins, and they literally open up emergency exits in this process, almost like a pressure release valve in a pressure cooker. The pressure, is really good in a pressure cooker, but if it gets too high, it can explode the pressure cooker. So we have a pop-off valve to release the pressure. And the same thing happens in mitochondria. Now, one of the reasons that happens is when we release these pop-off valves, we create heat. And we're warm-blooded animals. And so one of the main reasons to waste these calories is to produce heat. And in fact, we now know many people have heard of brown fat versus white fat. And brown fat is brown because it has so many mitochondria densely packed that it literally looks brown under the microscope. Whereas white fat, our traditional storage fat, has very few mitochondria, so it appears white under the microscope. And what we've known about brown fat for a very long time is that brown fat is used to generate heat. In fact, infants actually have a lot of brown fat because we think that they need to stay warm until they get enough body size and can get their own food. So they generate heat from this brown fat.
So just going back, let's define what you meant by that uncoupling of mitochondria. Tell us about that.
Yeah, so again, long ago when biochemists were trying to work out how many ATP molecules you could get from a molecule of glucose, and they were developing very sophisticated equations to define what went into a mitochondria to produce ATP. There was arguments back and forth between all these distinguished biochemists saying, no, mitochondria produce 34 molecules of ATP. No, in my system, they produce 32 molecules of ATP. And it wasn't until Sir Peter Mitchell from the UK proposed that, in fact, there was an electron transport chain that accomplished this. And his proof was the reason you guys are all getting a different number is that there are these pop-off uncoupling proteins that waste some of the fuel that you guys, don't understand from your calculation. And when these proteins were discovered, everybody says, son of a gun, is that guy a genius? Give him the Nobel Prize. And actually, the story of this man and his tribulations are well worth anybody's reading. He really persevered against huge amounts of criticism, and the guy was right. So hats off to Sir Peter Mitchell. So uncoupling proteins. My world was turned upside down when I discovered a paper by a PhD by the name of Martin Brand, who wrote a paper in the year 2000, not too long ago. It was called simply Uncoupling to Survive. Now, he proposed, and it turns out he was right, and he proved it, is that if you're starving to death and there isn't any food, then the mitochondria, which is the power plant of the cell, has to protect itself at all costs. Because if the mitochondria dies, that's it for us. And so the mitochondria needs to take action into its own hands. And here's the crazy thing. The more the mitochondria feels threatened with survival, with dying, the more uncoupling, the more fuel the mitochondria wastes to protect itself from damage. Now, again, that sounds crazy. If there's not much food to go around, why would you throw food away? It's to protect the mitochondria. And the mitochondria then devotes all of its energy to making more mitochondria to share the workload in making ATP, like adding dogs to the dog sled. And as strange as that concept is, Martin Brand then goes on to show that if you look at super old people who are thriving at 105 years old, they have the most uncoupled mitochondria of anybody. So now you go, whoa, I guess uncoupling mitochondria might be a really good thing to make me live well for a very long time. And fun fact that I talk about in the book, there's a theory of aging that's really called the cost of aging, the energetic cost of aging. And it's been a very popular theory. And briefly, in general, the higher your metabolic rate, the smaller the animal, the shorter the life. And in general, the bigger the animal, the slower the metabolic rate, the longer your life. And it makes really good sense, except birds. Birds are the problem with this theory. Birds in general are small. Birds in general live a very long time. Parrots can live 80 to 100 years. A hummingbird, a hummingbird in captivity can live 10 years. And I mean, this is a, it's got a metabolic rate, sky high. So it turns out that birds have the most uncoupled mitochondria. So even though their oxygen consumption, their metabolic rate is really high, most of it is protectively wasting that energy so that the mitochondria aren't damaged. And more we are beginning to realize that the mitochondrial dysfunction or mitochondrial damage theory of aging and of all really chronic diseases really starts to make sense. So if we can generate within mitochondria these protective mechanisms to keep them safe, to make more of themselves, then it really starts to add up. So this crazy idea that when you're in harm's way, you ought to waste fuel, that Brand said, yeah, that's what you should do. It turns out he was absolutely right. And so when you kind of look at this in a totally different lens, you say, wow, this is actually a really good design. And I certainly wouldn't have done it that way, but now I get it.
This is fascinating. So if the aging process is largely in a way related to mitochondria, and as you say, we have somewhat control over the state of our mitochondria, how much of our sort of health related fate is up to us then, and how much is out of our hands, would you say?
That's a great question. In my previous bestseller, The Longevity Paradox, there is a very important paper published in Nature just a few years ago that showed that only 8% of our fate is genetically determined, and 92% of our fate is determined by both the fate of our microbiome, the bugs that live in our gut, and these environmental factors like epigenomics. And so I mention that because in this book, I bring up one of the famous twin studies. And twins, are identical twins, have the exact same genes. They carry the same DNA. So there's absolutely no difference in their DNA. And yet we know that there are some twins where one is skinny and the other one is fat. And so researchers go, well, wait a minute, these guys have the same genes. They didn't inherit a fat gene from their parents that they shared. What's the deal? So when they actually looked at how their mitochondria were functioning, it turns out the fat twins' mitochondria were what they called lazy mitochondria. And that's not to imply that twin was lazy. That's not what the word means. But they were actually not, if you will, wasting energy. Whereas the skinny twin was was the Aston Martin, and the other guy was the Toyota Prius. So the other twin was actually uncoupling his mitochondria and wasting energy. That's why he could eat sometimes the same calories as the fat twin and be skinny. And it actually helps to explain why all of us have a friend who seems to eat huge amounts of carbohydrates, eats anything they want, doesn't exercise very much, and is stick figure thin, is twiggy. And then, some of us look at a croissant and gain a pound. And it actually helps to start explaining why, getting our mitochondria to protect themselves and waste energy makes so much sense, and why there are naturally skinny people and why there's fat people.
I think we've probably captured everyone's attention now with that 92% statistic. So if I were to ask you, and I'm pretty sure the answer to this question probably involves lectins, but if I was to say what foods you would encourage people to stay away from, what are the most detrimental foods people could be eating, what would you say?
Yeah, and you'd be right that one of our biggest problems of recent times are we eat a lot of foods that contain plant defense compounds called lectins. And one of the most famous is gluten in wheat, rye, and barley. By the way, for anyone eating their oatmeal this morning, there is a protein in oats that mimics gluten. So even if you're eating your certified gluten-free oats, I can assure you that oats will act exactly like gluten in your body. Sorry about that. So yeah, grains in general are troublemakers. Even, ancient grains like quinoa. There's two grains that actually don't have any lectins, millet and sorghum. So those are perfectly safe. Beans that have not been properly cooked or pressure cooked also are full of lectins. And the nightshade family, tomatoes, peppers, eggplant, white potatoes are actually loaded with lectins. Now, they're primarily in the peel and the seeds. And interestingly, cultures that eat these foods, like the Italians, always make tomato sauce after peeling and de-seeding their tomatoes. In fact, I'll tell you a fun London story. We mentioned off camera that I was a senior registrar at the Hospital for Sick Children in London at Great Ormond Street in my training. And one of my house officers was Bruno Murzi from Italy. And I decided to have Bruno and his wife over to our house and make him some spaghetti with tomato sauce pasta. And so I've got a can of tomatoes, and I dump them into the pan, and he's looking, he said, "Oh my God, what are you doing?" I said, "What?" And he says, there's peels and seeds. And I said, "Yeah, so that's how you make tomato sauce." He says, "Oh, do I have to teach you everything? Everybody knows you cannot make, pasta sauce with peels and seeds." I said, "What do you mean everybody knows?" He says, "They're dangerous. They're poisonous." And I actually had to look it up. And it's one of the starting points of where I said, wow, what does he know that I don't know? So wow. a fun London story.
Yeah, I love that. And this is what I love about the book. There's a lot of practicality in the do's and the do nots. And one of the do nots was don't eat lectin-rich plant foods. And one of the do's was do eat prebiotic fiber-rich plant foods. Now, what are some examples of those you can tell us?
Yeah, that's a great question. And most of us, sadly, now know that one of our problems with the modern diet is that it's so refined, so processed, that we've really eliminated almost all fiber from our diet. And sadly, the fiber that we're told to eat is what's called insoluble fiber, like bran. Unfortunately, our gut bacteria can't eat that sort of fiber. What they want is soluble fiber. Some of the best examples of soluble fiber is, for instance, asparagus is loaded with soluble fiber. The chicory family of vegetables, radicchio, Belgian endive, frisee, chicory, are loaded with soluble fiber. Tubers like yams and sweet potatoes or rutabagas are loaded with soluble fiber. And it turns out that study after study shows the more soluble fiber that we eat, that our gut microbiome, what I call our gut buddies, this is food that they actually have to grow and divide, number one, but they transform these prebiotic fibers into a term that most people still haven't heard of, that is called postbiotics. And the terminology keeps getting more confusing. Probiotics are friendly bacteria, and most people get that. Prebiotics are the fiber that the friendly bacteria need to eat. And when they eat the prebiotics, they make postbiotics, which are short chain fatty acids like butyrate, like acetic acid, vinegar, and a whole bunch of interesting gases that actually are signaling molecules that tell mitochondria what to do, tell our brain what to do. And one of the sad things is that one of the reasons we're all depressed and we're all anxious is that we no longer have a set of gut bacteria that are fed enough to make these compounds that really improve our health. And so the book is a guidebook of, okay, look, don't eat for your tongue, this 2x3 piece of muscle. Eat for your gut buddies. And if you eat for them, I guess what? They'll take care of you. Let me give you a really important study that I mentioned in the book. They took some Chinese volunteers and they put them on either a 7 or a 14-day water fast. That's all they got. And anyone who's tried it, it is challenging, and you get pretty doggone hungry after a few days, and then it gets better. But they divided it into two groups. In one group, they gave 100 calories a day of prebiotic fiber. Now, the important point of that is we cannot digest fiber. We cannot get any calories out of it, but our gut microbiome can. And so what they found with just 100 calories of prebiotic fiber, the group that got that had absolutely no hunger despite 14 days of just water. Now, why is that? Well, these researchers propose, and I like it a lot, the gut-centric theory of hunger. And that is that our true hunger actually comes from our gut microbiome. And if we give them what they want to eat, they go, hey, yep, our needs are met, we're good, carry on. But with our food, we've starved the gut microbiome. And so we're constantly hungry because they're going, what the heck? You keep eating and there's nothing coming down here for us. Go find something. And I really like that theory. And I think it explains and gives people some hope that if we just, manipulate our diet and eat some of these foods, it's amazing how the cravings go away.
Yes, it's interesting. There was one part in the book you said that our sort of hunter-gatherer ancestors consumed 150 grams of fiber each day. Now we consume about 5.
Correct.
And a lot of people are going to try and combat this by getting high-fiber cereal. They're going to go to the supermarket and grab anything with the word fiber on it and think it's doing them the world of good. Now, what advice would you give to these people who maybe aren't educated enough on this subject and they see the word fiber and they reach out and grab it? What would you advise them?
So unfortunately, one of your fellow countrymen, Dennis Burkitt, who is an English surgeon, was the cause of this misconception. And Dennis Burkitt was a intestinal surgeon, a colon surgeon, and he did missionary work in Africa. And when he got to Africa, he couldn't find anybody to operate on. He couldn't find Africans with hemorrhoids. He couldn't find Africans with colon cancer. He couldn't find Africans with diverticulosis, diverticulitis. And he's going, what the heck? You know, this is all over England. You know, I got a great job in England. You know, where are these people? So he started following them around, and he became obsessed with bowel movements of Africans. And these Africans were eating tubers. They were eating, you know, yams, and their bowel movements were huge. I mean, there were literally termite mounds of bowel movements. And he says, oh my gosh, you know, look, these guys are eating all this fiber and they got giant bowel movements and they don't have any of, you know, of our colon diseases. So he comes back to the UK and he said, that's it, you know, fiber, that's the key. Now, unfortunately, the UK, like America, has not a lot of soluble fiber foods in our diet, but we had a lot of insoluble fiber foods and grains. We had plenty of wheat, we had plenty of rye, we had plenty of oats. And he says, well, fiber is fiber. So I want everybody to eat a high fiber diet, and here it is. And that actually started people on the wrong path, because the fibers in these sort of things are loaded with lectins. And lectins are literally simplistically like swallowing razor blades. And they literally poke holes in the wall of our gut and cause leaky gut and inflammation. And there's actually some very cool papers that show that insoluble fiber works by literally scratching the inside of the gut wall. And of course, you're going to have a bowel movement because your body says, holy cow, I got to get these guys out of me. So, and Dennis Burkitt was very famous. He discovered a lymphoma that still carries his name. So, and he was right that fiber was the key, but he got the type of fiber wrong. Darn it. So the point is, most of the high fiber foods you see in the grocery store, you know, even whole wheat bread or, you know, high fiber cereal, these are actually put them back. They're the wrong fiber. Instead, you know, for instance, an avocado is densely rich with soluble fiber. So as I talk about in the book, buy an avocado, take the pit out, put an egg yolk in both sides of the pit, put it in the toaster oven or in the broiler, and pour some olive oil on it, salt and pepper, and eat it with a spoon. And you'll have actually a perfect high fiber ketogenic meal for breakfast if you want it. Amazing. Or lunch.
Yeah, I mean, so this is something I'd love to get your take on. We've had guests from all over the spectrum on the topic of diet. He's a good friend of the show, Dr. Will Bolshevich. He wrote Fiber Fueled. He's a big proponent of the vegan diet, plant-based diet. Then I've had someone on the show like Dr. Ben Bickman. There's a lot of insulin resistance work. Now, he said he was vehemently against veganism. What could you advise us on this debate between the plant-based and the carnivores?
Sure. Well, I spent most of my career as a professor at Loma Linda University in Southern California. And Loma Linda, for people who might recognize the name, is the only blue zone in North America. And those are blue zones are people who live an extremely long time. And the Adventists, the religion, are primarily vegetarians and vegans. So I see a huge number of vegans and vegetarians in my practice. And I can tell you, and I have, believe it or not, in every one of my books, a vegan recipe version and a vegetarian version of every one of my recipes. I believe in eating mostly plants, but plants that don't want to kill us. And a lot of plants really do not like us. They don't want to be eaten, folks. Some of my sickest patients, when I first see them, are vegans. Now, part of the problem is that in the West, veganism is in general pasta, grain, and beanitarians. And so if you wanted to have a deadly diet of lectins, that's what you need to do. On the other hand, a gorilla or a horse are also vegans, but they don't suffer at all. They get all their muscles from eating plant compounds, but their leaves and grasses. So I'm a veg aquarian. Primarily, I eat leaves and plants that don't do me in, and I add wild shellfish primarily on the weekends, and that's been my diet. On the other hand, many people tell me that I am the father of the carnivore diet because the carnivore diet eliminates most all lectins, and so I can tell you, as I talk about in the book, that I take care of a few people who experiment with the carnivore diet in a carnivore keto diet. And even though they feel great initially, when we look at their blood work, and I do blood work on all my patients every 3 months, and I see patients 6 days a week, even on the weekends, we see changes in their blood work of inflammation on the inside of their blood vessels. We see changes that their blood vessels, which should normally be very flexible, become stiff. And it's almost like the scene from Jaws, where you've got this lovely young lady swimming on the ocean, and she doesn't know that right under her is a great white shark about to bite her. And when I show these people, these results, and it's consistent, they go, oh my gosh, what was I doing? Well, part of the problem is, to get back to our previous point, these diets are devoid of soluble fiber that our gut microbiome wants to eat, has to eat, and it produces compounds that actually makes our blood vessels flexible, stops inflammation. So vegans, the way we practice it, is a really mischievous sport. Carnivore diet and most of the high protein, high fat keto diets, same problem. It's bad stuff is going to happen. So my program is, hey, let's meet in the middle. Here's the good stuff about eating plants. Here's the bad stuff about eating plants. Here's the good stuff about adding animal protein, and here's the bad stuff.
Very, very interesting. Well, on the topic of protein, one last thing before we start to wrap up. In the do's and don'ts, which is my favorite part of the book, you say don't overdo it on the protein. Now, I've worked in gyms all my working life, and I see hundreds of people a day who come in and they're obsessed with protein. They're buying protein snacks. They're doubling up the protein on every meal, protein shakes. Why shouldn't we overdo it on the protein like all these people tend to do?
Well, first of all, there is actually not much human need for protein. If you're actively building muscles, then certainly adding more protein to your diet is a reasonable thing to do. But one of the things, the famous Dr. Atkins of the Atkins diet, he was originally a high-fat doctor, and he was a cardiologist. He got into so much trouble with the American Medical Association that accused him of being a murderer, that he morphed into a high-protein doctor. And after he changed from a high-fat diet to a high-protein diet, he began to get fatter and fatter. And many people know that he actually died as an obese man, fairly young, at 72. So we don't have a storage system for protein except our muscles. But we do not waste calories if we're eating them. So we convert protein into sugar. It's called gluconeogenesis. And so many of my patients who embark, on a high protein diet don't realize that they have an elevated insulin level, and we won't talk about that today, but they'll convert that protein into sugar, and then they'll convert that sugar, they'll store it as fat. And so many of the folks who come to see me are frustrated that, they're not losing any weight, even though they're going to the gym, every day. In fact, I just saw a woman this past week that is gaining weight. She says, I don't get it. I'm going to Pilates every day, and I work out on my exercycle an hour every day, and I'm jogging, and I've gained 10 pounds in the last year. And so I look at her diet and I go, well, no wonder, you're having the protein shake before you work out, and then you're waiting 20 minutes, and then you're having another protein bar or protein shake. And I said, you're just converting it, I'm sorry, into sugar and then fat. So I hope that explains some of that.
Yeah, that's extremely, extremely interesting, especially in my field of work. Before we wrap up, I have two final questions. The first one, obviously, your brand new book, and all your books have undoubtedly impacted so many people. But what books have you read in your life that have had a big impact on who you are today?
Oh, wow. Actually, I'm going to give a shout out to one of your countrymen whose book I happen to have sitting on my desk. There he is, Tim Spector. And I really highly recommend The Diet Myth. Tim and I have come at this from different ways. He actually heads the twin study in the UK. And he has, through the years, completely changed his view on diet. And I think I've had him on my podcast, the Dr. Gundry podcast, and I really appreciate his thinking. He made me really re-examine my feelings about where cheese fits in our diet. And in the book, I give a shout out to goat and sheep cheeses and goat and sheep yogurt, because believe it or not, they're loaded with medium chain triglycerides. So what an easy way to get MCT oil into your mouth. And so don't be afraid of particular cheeses. So amazing. Shout out to Tim Spector.
Tim Spector, fantastic recommendation. But the last question I have for you, as I ask every guest, is nothing to do with the topic of discussion. It's all about you. The answer could be anything. It could be your work, it could be your family, your friends. But right now, for Dr. Stephen Gundry, what makes life worth living?
Oh, showing up to work every day, and believe it or not, watching miracles happen to people who really thought it was their fault, that it was their problem, and there was, it was all in their head, and watching things turn around when you teach them how to eat. And, I'm like a kid in a candy store, and that's why I show up. I literally see patients 6 days a week. And on the 7th day, I'm actually at my food and supplement company, Gundry MD. So I work 7 days a week. That's why I get up every day, because I get to watch miracles happen. And I learn from every one of my patients. So how blessed am I?
Beautifully put. Well, where can our audience find more from yourself? Where can they find the book and connect with you, your podcast, your social media? Where can they find you?
Yeah, so they can find me at drgundry.com, my food and supplement company, gundrymd.com. I've got 2 YouTube channels. I'm on Instagram, the Dr. Gundry podcast, wherever you get your podcasts. The books have been national and international bestsellers. They're very popular in the UK. It should be available wherever you get your books, Amazon, but preferably go to your local bookstore. COVID has been an absolute disaster for everybody, but particularly small booksellers, and they really need our help. So, and they'll have the book, because like I say, I've been a bestseller in the UK, which I appreciate, everyone.
Amazing. Well, congratulations on another amazing book. I'm sure there'll be another one to come. And thank you so much for joining me today on the podcast. It's been an absolute pleasure, sir.
Well, and thanks for having me. I really enjoyed it.